And hi everyone, this is a SIG Scheduling meeting, 30th April 2026. We have 3 items in our agenda, so we can start with the first one. So you
Hi, my name is Min. I am from Amazon EKS. So I sent this issue because we noticed some performance degrading issues in scheduler. If you can open the link to the issue, please.
Yes.
Thank you. Right. So what we found is that when we're testing the path scheduling throughput, we found that when all the paths when all the incoming paths has PVC mounts, the throughput will drop like exponentially over time. Now, if you scroll down, this is a graph showing the how the throughputs look like. The So by the definition, the throughput means a pause per second. That in our test suite. So we noticed that when we start the this bench test for schedulers, the throughput was around 1000. However, as the time goes down, as the time goes by, it just keep dropping. I don't think it's I don't think it has an end. It keeps dropping all the way until all my pods get scheduled. So the at the end of my test, I think I scheduled 20K 200K pods, and the throughput will drop down to 30-ish from 1000. And this test was done by the cluster loader 2, the performance testing. This is a standardized test suite. So I did a further look into this issue, and I found out that this performance degrading issue is caused by the one of the PVC related aggregations during the node during the snapshot building, the cache snapshot building phase. So essentially, I if you scroll up to the if you scroll up a bit, um, thank you. Yeah, there's a code link there, and this is where we inside each scheduler cycles we run this logics when we loop over all the node list, and we also loop on the all the PVCs and manipulate on this set this is set data structure, and this is where the time cost coming from. So yeah, this is and this is what we found, and we did another. Uh, we we know that this is these three lines is the root cause, not only by this this CPU profile that you're looking at, but also we had a private patch to move this PVC related aggregations to the to what's that the parallelizer, the so that we can move these PVC related aggregations into a separate code block, and utilize the parallelizer to process all the PVC related aggregations. As far as I know, I think this three lines so far it's only used for the node volume scheduler plugin. That's for enforcing there's only one like pod mount for each PVC. So that's a and we move that when we move that to the parallelizer, the throughput doesn't drop like at all. So it was very steady. So I hope to report this issue and see what I can do to kind of contribute this issue, to contribute the patch to the community.
Okay, yeah, that's interesting topic. It definitely this looks like a bottleneck. And parallelizing looks promising. The question is if we can do something like to avoid iterating over all counts and inserting them into the snapshot, like because like in the snapshot we only need to change the diff between the previous snapshot and the new one. So maybe we can do something better here. and also parallelize if we can.
Yeah. And what kind of diff are you thinking about? Could you elaborate?
Yeah, like because in the snapshots, like if we have this code, and we don't want to like recreate the whole snapshot from the cache in each for each scheduling cycle. We only uh, update it with the difference what changed in the cluster in the meantime.
Mm-hmm.
So maybe we could, and for the PVCs, I see we just copy all of them, even if they like haven't changed or changed only slightly. So maybe we could track what changed and only apply such operations.
Yeah. I think I can share more about the patch we had for um fixing this issue temporarily. I what we did is we moved this PVC aggregations into what's that? Uh, sorry, just give me 1 second. Yeah, so we know that at the moment this logic is only used by the volume restriction scheduler plugin, right? So we what I tried is I moved this logic into the pre-filter hook of the volume restriction plugin, so that we don't need to do this for every in the every scheduler cycle. I'm not sure if we put this here uh, for some kind of forward compatibility for more future extensibility, but it look at this point it looks like over engineering. If we can move that to pre-filter, that so that the only uh, plugin that benefits from this logic needs to need to like do this. I think that makes more sense. What do you think?
And like, I'm not sure what were the reasons why it's here. Like, I'm not sure if we really can move that inside the plugin, as theoretically there could be some external plugin that needs such a field, but I'm not sure if that's it, if that can be a case. So if there exists any plugin that really benefits from it, except the volume restrictions. I think if you are happy, you can open a PR with your idea and we can review that then.
Yeah.
Also, I think SIG Storage could chime in because I think they own the plugin. So maybe on that level, we could further discuss this issue and maybe
Oh,
come up with some improvements,
uh,
further improvements.
can I get the GitHub handle of the like the company, the person you say own this plugin?
Like it's the separate SIG. It's so the SIG storage
SIG
group.
storage. Okay, okay.
Yes, so they like own the logic of the plugin, but obviously we own the scheduler, so we also
Yeah.
may have.
On the other hand, I think we're not changing the logic of this plugin. It's more like moving this aggregation logics from one place to another.
Yes, so I think it would be the best if you open a PR with
Okay.
like the change that works for you, and we can further discuss it there.
Okay. And do you think we should make this feature gate, or we should just make it as a just a direct patch?
I am not. I don't think we need a feature guide for this. It's
Okay.
kind of localized change.
I see.
I
I
think we
see.
can test it well before merging.
Yeah. 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 Thank you so much.
All right, yeah, thanks for bringing this topic today.
Thank you.
All right, so we can move to the second topic that is from Roman Baron about the opportunistic batching.
Can I share my screen maybe?
Yeah, sure. Should be, I
Okay.
will. Yeah.
Tell me if you see it.
Yes.
Okay, great. So the topic I wanted to talk about is related to opportunistic batching. I'll share some background for people who might not be well aware about this feature. Basically, opportunistic batching is a scheduler optimization for scheduling many similar pods in a sequence. The idea is that all those pods need to have the same scheduling signature that is derived from the scheduling constraints of those pods. And instead of running the filter and score pipeline for every pod, the scheduler runs filter and score for the first pod. Then it captures all the feasible nodes ordered by their scores. And then it simply assigns the first pod to the first node, the second pod to the second node, and so on. And it is efficient because it basically spares the need to run the filter and score every time. So it runs only once for the first pod. And all the subsequent pods, they reuse the ordered node list from the cached nodes in the batch. And the idea is that the current design follows a very specific pattern. It supports this one pod per node pattern, and there is a good reason for that. It's because when we assign the first node to the first pod, it moves out from the list because the node is no longer available for the second pod. Because of that, the cached node list remains ordered, and basically the scoring is still valid for the second pod and on. So the scheduler doesn't need to recompute the scores of those nodes. And in addition to that, there is also some limitation that I saw lately, is that it also relies on node local scoring plugins. So plugins like pod topology spread and pod affinity node placement, pod placement can also affect scores of other nodes are explicitly excluded from this feature, meaning that pods with the pod affinity constraints are simply not signable, and they go through the full pipeline with the filter and score. And the reason I'm talking about this feature is because we have this issue that was opened about a month ago, that basically calls out on a specific use case that breaks this optimization. Basically, since the current design mainly targets the one pod per node pattern, it is possible that in the same cluster there will be other workloads where multiple pods can fit into the same node, for example, because they simply request very few resources. And the previously chosen node can remain feasible from the next pod as well. And the issue basically explains why there is a specific performance penalty that those workloads pay, and they cannot leverage opportunistic batching at all, because every cycle the batch cache flashed. Again, because of the one pod per node pattern that is not met. So in this issue, we discussed it for a while, I think, with many participants, and eventually I think that we agreed that the suggested solution, or at least the one that multiple people suggested, is simply rescoring the node again. So if the last assigned node is still feasible for the next pod, we can rescore only that node and insert it back to the order list, and then continue using the opportunistic batching as before. And I think that on my end, the main points to discuss at the moment, or the open questions that I also wrote in this doc, is first how to implement rescoring, because we have more than one option. We can either reuse the existing score and normalize score extension points and cache the raw scores of the cached nodes in the batch. Or the other option was to introduce a new rescore extension point that can be used to rescore both the last chosen node, and maybe also the related nodes as well. This way, for example, a plugin can apply new scoring for related nodes as well, and not only for the last one. Basically, I personally prefer the first option because it's it seems more straightforward, and also I'm not sure if introducing a new rescore extension point that will require future support and maintenance, and probably it will also require other plugins to implement it as well, is acceptable for an optimization. But at the same time, even with the first option, we can later introduce it, and it will fit well into the suggested design that I made. So maybe I'll stop for a second here for questions, and also if anyone has a strong opinion about this open question, that's a good time for that.
Yeah, so I agree with your conclusions to reuse what we have. We still doesn't support the like group plugins, right? So just option A is much better right now, and we can just do the option B in the future.
I also think that maybe enabling rescoring or or actually supporting this feature with group-aware scoring plugins will be much bigger challenge than the new extension point itself. So maybe after this change, it will make sense to enable them and then wrap it nicely with a new rescore extension point if we choose to do so.
That's right, yeah. But about these group level plugins, that is one case that we would like to support sooner than later, which is the default topology constraints. I think we should find some solutions for that, because by default the batching won't work on the default scheduler still, because there are some default topology rules. So then if pods are not from the service at Citira, they still cannot benefit from the batching. But yeah, it doesn't have much connected with the scoring topic. I just want to bring it up.
Yeah, probably one step at a time.
Yeah.
Okay. The second point to discuss is that it's not really a question or a concern, but one of the things that I spent some time thinking about is that the fact that we cache the feasible nodes list, and then if the last node is still feasible, we want to rescore this one node once again because we just placed a new pod on it. But then we will also need to normalize the scores of all the cache nodes together, because now the normalization can be affected, and other nodes normalized score can be different. And at the beginning, I wonder if there is any potential problem that it might cause. But eventually, I think that I understood that as long as the cached node list is valid, as long as it's fresh, and as long it is identical to the feasible nodes that would result from running the filter and score pipeline again at the same moment, then the normalization is probably valid as well. But
yes, I also think that. Yeah.
But if anyone sees any possible problem with that, then it would be a good time to bring it to the discussion, because I don't know.
Like maybe the only issue is that if we go to the next scheduling cycle, we'll have the group, the list of cached nodes computed at some cluster state, and then the one node that is computed on the different cluster state. So its score will be based on a different state than the score of the other nodes. But I don't think it's a huge problem.
Which is also which can also happen without opportunistic batching, right? It depends on the how fresh is the snapshot.
Yeah, scheduler is eventually consistent, so the snapshot still doesn't capture the real cluster state, but some cluster state from some point of the time before, right? And even it can capture some theoretically non-existing state because each API object has its own ordering.
Right.
Yeah.
Okay. And the third point is that I wanted to hear your opinion about introducing a new feature gate that will guard the new design, because we already have a feature gate for opportunistic batching, but I wanted to keep the option of disabling the rescoring only part and falling back to the existing functionality with the one pod per node behavior that we have today.
Yes. So
Is it
I
an
put list of
overkill or a good idea?
I said in your cap that I would remove this feature gate and use only the opportunistic batching. For me, it's localized feature, right? So it shouldn't rather break anything if the batching itself doesn't break anything. So in my opinion, we don't need that.
Okay. Okay, I didn't see your comment yet, but that's like a good point maybe to mention that I also opened a cap with the suggested changes. It is based on the existing opportunistic batching cap that we have today, and I saw that you suggested like to refactor it and split it into two separate caps, one for the refactoring. I agree with that. I did that mainly because I wanted to understand what exists and what needs to be added, just to be sure that I don't simply follow the general like suggestions to add more tests, and I wanted to see what exists and what I want to add for scoring. So I will split into two separate caps. The refactoring related one should probably be simple, and then we will remain only with the changes.
Yes, sounds good.
Cool. Any questions or comments on this topic? That's it then.
Thanks for working on that. Yeah, so now we have one more point left. I just wanted to say like something about the 137, the incoming release. So yeah, from the SIG scheduling perspective, we still keep our priorities from the 136. So the workload level scheduling will remain as a top priority, with the beta graduation of workload API and CAN scheduling as a topmost priority. And it will also require the workload level preemption to be also implemented and graduated to beta. And after the whole workload level scheduling, like we will prioritize other caps if they happen, so including the batching. Obviously, we will review them, but if we have to choose, we will push the workload level scheduling to be implemented. And yeah, that's about the like initial priorities of that. We'll also come with something more formalized in the nearest weeks. So we will have all the priorities right down, probably in our dashboard, so they are visible to all of you. And yeah, and also we want to formalize the reviewing process similarly as we did for 137, for 136. As the number of contributions grow, the number of reviewers grows, but slower than the number of contributors. So once again, we will just have in the dashboard the first and second reviewers to like spread the reviewing on all the reviewers in some balanced way, but also for the authors of the PRs to know from whom they should expect the review. So yeah, please stay tuned. In the incoming weeks, we will propose some more details on that. All right, that was all from me. So do we have any other topics or questions or anything? Or shall we conclude the meeting?
Thank you. Bye-bye.
Yeah. So thanks all for joining. See you on the next meetings. Have a nice day and weekend. Bye.
Thanks. Bye.
Thank you. Bye-bye.